let's look at perfect squares and perfect cubes. But the problem with perfect squares and perfect cubes is that look at the size of that number. You got 1764. That's a huge number. Best way to do it? Yep, everybody's favorite factor tree. But here's the problem. If you start dividing this by 2, you're going to get a factor tree that's going to be like absolutely ginormous. So my suggestion to you is instead of dividing by 2, look at, since you are after a perfect square, look at all of the small perfect squares to begin with. For example, 1 squared, Neo. 2 squared, golf game. 3 squared, that beautiful German girl that says no to me all the time. 4 squared, 16, that's you. 5 squared, 25. If I had a quarter for every time I did this. 6 squared, hey, let's try some of these numbers. I'm going to go and be as bold because I know what the answer is. I'm going to try 36. The way you do it, pop open your calculator. There we go, there's my calculator. I'm going to put in 1764. And I'm going to divide this by 36 right now and watch what happens. Lo and behold, it's 49. Now, the reason why I tried that, again, is because I tried some of these perfect squares first, bigger numbers, giving me 36 here times 49, which becomes super easy to do. Now we can continue the process, break this down to 6 times 6, this to 7 times 7, and you're going to notice something here. Watch this. I'm just going to rearrange this for a second, just to show you something incredibly cool. So I'm going to rearrange this to be 6 times 7 times 6 times 7, and look at this. Look at that right there and right there. There's your pair of numbers, making 1764 a perfect square of, guess what? 6 times 7, which is, watch this, 42 times 42. It is a perfect square. Check that out. So I'm going to bring up my calculator here for a second, and I want to prove that to you. Look at this. 1764 is 42 squared. Perfect squared. There it is. Isn't that neat? It's awesome. So when you get to that point like this, that makes this a perfect square. Bang on. You don't have to do anything else. It's good to go. Now, let's go and look at the next question. The next question is, how about 4096? How about 4096? Well, again, I'm looking at perfect squares and perfect cubes, so I'm going to go through it. Yeah, 1 squared, Neo from the Matrix. 2 squared, my golf game. 3 squared, that beautiful German girl. 4 squared is you guys. 5 squared is 25 for every quarter I've had to do this. 6 squared, 36. 7 squared, check this out, that's 49. 8 squared, and I know I'm going to go up to this. I'm going to go up to 64, but I want to show you something really cool. I'm going to tell you right now, 4096 is 64 times 64. Watch this, and I'll prove it to you, which is really, really cool. Go to your calculator. How do I know that? Because I'm going to take this calculator, I'm going to go, okay, 4096, and I'm going to divide it by 64. So I kind of am on the inside of this. I kind of know where this question is going to go because I designed this question to be that way. So it's going to be 64 by 64. If you're not sure, try these numbers. See what you get. See if it gives you a nice number. Go from there. Now, check this out. This being a pair, check this. This is the best part. This being a pair, I know that it's a perfect square because 64 squared gives me 4096. But I want to go one more step. I want to go back to this 4096 and I want to see if this in fact is not a perfect cube as well. Here we go. 64 I know is 8 times 8. This is 8 times 8. So look at this. Look at that. That means it's not a perfect cube, but it's so far, it's a perfect fourth, right? There's 4 of them. So you can actually take the 4th root of 4096, and that would give you 8. So right now, it's a perfect 8th, but let's keep on going. Let's see what happens. This I know is 4 times 2. 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 Let's keep on going. Let's keep on going. Watch this. This is 2 times 2 times 2. This is 2 times 2 times 2, right? This is 2 times 2 times 2, so we need 3 2's for that one. Okay, this is 2 times 2 times 2, so we need 3 2's for that one. But remember, we're looking for perfect cubes. We're looking for perfect cubes. So we're looking for 3's. We're looking for 3's. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Wait a second. Can we break this up into perfect 3's? Okay, I want 2 groups of 3. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Can we break this up into 3 groups of something? Sure. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Oops. Look at that. You've got 3 groups of 4. So 3 groups of 4 is 2 times 2, which is 4 times 2 is 8 times 2 is 16. That's 16 times 16 times 16th. Guess what? The cubed root of your original number, which was 4096, is actually equal to 16. Isn't that amazing? Just by looking at the factor tree. So that's where this comes in. A number can be both a perfect square, a perfect cube, and in this case, not only is it a perfect square and a perfect cube, it actually ends up being a perfect fourth as well.